Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Reinforcement Learning in Action. AI that learns by doing in the real world. Welcome to Reinforcement Learning in Action. Imagine teaching a dog tricks. Or learning to ride a bike yourself. You try something. You get a result, good or bad, and you adjust. That's exactly what reinforcement learning, RL, is for AI. Instead of us programming every single step, we let the AI learn by doing things in an environment and getting feedback. It's about AI discovering the best way to achieve a goal through trial and error. Much like an intelligent agent exploring the world. To understand RL, let's meet the key players. As a developer, you'll be defining these. Agent. This is our AI. Think of it as the student learning, for example, the AI trying to ride the bike. Environment. The world the agent lives in and interacts with. For our bike riding AI, it's the road, obstacles, gravity. For a game AI, it's the game world itself. Action. What the agent does in the environment. Pedaling, turning, braking for the bike, moving a character in a game. State. The current situation of the agent and its environment. I'm on the bike, going downhill, approaching a puddle. This is the information the AI observes. Reward. The crucial feedback from the environment. Great job, you stayed upright. Quote, plus 10 points. Or, ouch, you crashed. Quote, minus 5 points. This score guides the AI's learning. This is where the magic happens, the continuous loop of learning. 1. Observe state. The eye looks at its current situation in the environment. 2. Choose action. Based on its current understanding, or just guessing initially, it picks an action to perform. 3. Execute action. It performs that action in the environment. 4. Receive reward and new state. The environment reacts, telling the AI how good or bad that action was. The reward, and what the new situation is. The new state. 5. Learn and repeat. The AI then updates its internal strategy, called its policy, to try and get more positive rewards next time. It repeats this process thousands, even millions of times, constantly improving. As developers, we don't code the AI's every move. Instead, we build the framework for its learning. Designing the environment, we create the digital world the AI will learn in. Often, this is a simulation. Think of writing the physics engine for our bike riding AI. Or the rules for a game world. We're building the sandbox for the AI to play and learn in. Crafting the reward function. This is arguably the most critical part. We define what winning or losing means. For example, staying upright for 10 seconds equals plus 1 point, crashing equals minus 10 points, reaching the destination equals plus 100 points. A well-designed reward function subtly guides the AI towards the desired behavior, without us explicitly programming how to achieve it. Selecting the learning algorithm. We choose the underlying RL algorithm, e.g., Q-learning, policy gradients. This algorithm is the brain that processes the rewards and states to continuously update the agent's policy. RL isn't just for beating Go champions or mastering video games. Its learn by doing approach has powerful real-world applications. Robotics. Teaching robots to walk, grasp delicate objects, or navigate complex, unpredictable spaces. Imagine a robot arm learning to assemble products by trying different movements. Self-driving cars. Training autonomous vehicles to make real-time decisions in traffic, like merging lanes or reacting to sudden obstacles, by rewarding safe driving and penalizing accidents. Resource management. Optimizing energy consumption in large data centers or managing traffic flow in smart cities to reduce congestion. Personalized recommendations. Systems that learn your preferences based on your interactions, what you click, watch, or buy, and reward themselves when their recommendations lead to engagement. After countless trials, errors, and reward signals, the agent develops a highly optimized policy, essentially, its ultimate strategy for navigating the environment and maximizing rewards. It learns not just to avoid crashes but to ride efficiently, make optimal turns, and maybe even discover clever shortcuts. This is the aha moment, when our AI transitions from random guessing to expert performance. Having discovered the solution entirely on its own, it's truly a captivating display of self-discovery and intelligence. Reinforcement learning is incredibly powerful but comes with its challenges. Data hungry, it often requires a vast number of trials, which can be time-consuming, especially in real-world scenarios. Reward design, crafting the perfect reward function that guides the AI to the exact desired behavior without unintended side effects can be tricky. Sim2 Real Gap. What an AI learns in a simulated environment doesn't always translate perfectly to the messy, unpredictable real world. But this is where you, as a developer, come in. You'll be designing these environments, crafting clever reward functions, and choosing the right learning algorithms. RL is a cutting-edge field with immense potential. And with your coding skills, you can build AI systems that adapt, learn, and improve autonomously. Get ready to experiment and see AI learn by doing. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.